Hey, it's Caveman Drew. So I was entertaining myself watching videos about folks who believe in the flat earth theory. And some of them put up some very interesting arguments about the proof they've uncovered that NASA is lying to us. That those who position the globe theory of the earth are lying to us, and that in fact we do live on a flat earth. And my video is not intended to prove or disprove the flat earth theory or the globe earth theory, but I did want to comment on a video I came across which suggests that the moon is not as far away as scientists would have us believe. This video I came across is called 100% Undeniable Proof the Moon is Close and NASA Lies. Flat Earth. Put out by a YouTuber with the name The Potter's Clay, who actually does have a good collection of interesting videos. Feel free to go check them out. But I would like to talk about this particular video and my thoughts about why it's probably not the best quote-unquote proof. It starts out by saying, I think it's time we talked about the moon. The proof centers around an examination of a crater on the surface of the moon known as Tycho. The Tycho crater is visible with the naked eye, and so the attempt here is to prove that the moon cannot possibly be as far away as it is, given the fact that we can see Tycho with our naked eye. Scientists are telling us that the diameter of the Tycho crater is 86 kilometers. They also tell us that the mean radius of the moon is 1,737 kilometers, or 3,474 kilometers in diameter. Science also tells us that the moon, in its imperfect orbit around the Earth, at its nearest point, the perigee of its orbit, is 362,600 kilometers from the surface of the Earth. So again, the video tries to suggest that at a distance of over 362,000 kilometers away, how can we see an object that is less than 90 kilometers across? Seems impossible. To make this easier to conceptualize, the video attempts to suggest we look at something a little bit closer to Earth's scale, and we look at Long Island, which is about double in length the size of the diameter of the Tycho crater. And the suggestion is, at scale, if you were to stand in London, England, would you be able to see Long Island? Something twice as long as the diameter of the Tycho crater? And that of course seems absurd. But this is not really a very good proof, considering on a globe Earth model, the curvature of the Earth would preclude you from being able to see Long Island all by itself. But how about on a flat Earth? Would you be able to see Long Island from the distance of 3,456 miles away, standing in the town of London, England? This too is a weak argument because, first of all, Long Island is relatively flat. We're not talking about an object that is as tall. Would we be able to see it from that distance? Maybe something spherical from that distance away. And we're also not looking through an absolute vacuum. So you have air between your eyes in London and this large object across the ocean. And you have light scattering on objects that are within the air, and all sorts of other things which would preclude you from being able to see it anyway. So perhaps if we were suggesting an example in a vacuum, this might be a more acceptable example. But let's throw it out. The video brings the scale down to something even smaller. So in the video they do some simple math and they come up with a smaller example at the same ratio. And they talk about looking at a child 4 3/4 feet tall. At scale, that child would be standing 4 miles away. So we're pretending the child is the size of the Tycho crater, the distance of the Earth from the moon, scaled down to the size of a child, 4 3/4 feet tall, 4 miles away. Would you be able to see that child standing 4 miles away? It kind of seems a little ridiculous. So I decided to do my own quick analysis. Let's look at the moon again quickly. I took a more high-definition image of the moon, and when I cropped it, I ended up with an image of 3,228 pixels by 3,228 pixels. We know the moon is not an absolutely perfect spheroid, but in the case of my analysis, I did come up with a square box. From that same image, I cropped out just the image of the Tycho crater, and I came up with an image 79 pixels by 66 pixels. Now if I rescale my image to 3474 by 3474 pixels, I have a 1 pixel equals 1 kilometer scale to the actual size of the moon. If I scale out the Tycho crater by the same amount, a factor of 1.0762, I end up with an image 85 pixels by 71 pixels. So let's take the 85 pixels as our widest part of the diameter of the Tycho crater. We have a wider part of the Tycho crater simply due to the perspective difference due to the curvature of the moon, assuming it is a sphere. We have a small margin of error because we're not exactly sure what to call the exact edge of the crater. But in any case, since the scientists tell us the diameter of the crater is 86 kilometers, I would say that our size of 85 pixels correlates very closely with that. And scientists tell us that the moon is 3,474 kilometers in diameter, which of course matches to the scale of the image we created. I would have to say that the numbers the scientists are giving us are correct in relationship to each other for the size of the crater to the size of the moon. Fine. Now the moon is said by these scientists to be at its closest point, the perigee of its orbit around the Earth, to be 362,600 kilometers away. Are those bastards lying to us about that too? Well, let's pretend we're standing on that closest point on Earth to the moon at that point. So we have the ratio of the object diameter to the distance away of 3,474 to 362,600, or 1 to 104.375. We could take that same ratio now and bring it to a smaller scale. Let's say we have a 6-foot tall man. At that same ratio, that 6-foot tall man representing the moon would be standing 626.25 feet away. Can you see that man? There's 5,280 feet in a mile, so we're talking about a man standing 0.119 miles away, a little more than 1/10 of a mile away. Can you see that guy? Absolutely, you can see that guy standing there, just as you can see the moon up in the sky. Okay, so again now, what about that crater? The crater is at a ratio of 86 to 3,474, if you think about the size of the crater ratio to the size of the moon. That's the same as 1 to 40.395. So let's pretend our man is wearing a t-shirt with a picture of the Tycho crater to scale with his height. So the picture on the man's t-shirt of the crater is 0.1485 feet, or 1.782 inches tall. Now think about this. Can I clearly see a almost 2-inch tall spot from about 1/10 of a mile away? Perhaps, right? Think about it. When you're driving down the highway, oftentimes there are mile markers every mile, and then you have incremental markers between them every 1/10 of a mile. As you're driving down the highway, can you see the number that's on that mile marker, that 1/10 of a mile marker? Yeah, if you have decent eyesight, you can probably see there's a number on there. So 1/10 of a mile is 528 feet. If we scale out the distance that our 6-foot man was standing away, we basically now can say, instead, let's look at a spot that is 2.114 inches tall at 1/10 of a mile away. It's exactly the same ratio. Can I see that 2.114 inch object from 1/10 of a mile away? I absolutely bet you that I can see that small object. It's only 1/10 of a mile. Now, let's talk a little bit more about how well we can truly see the Tycho crater with the naked eye. Now, anytime you've seen this crater in this video up to this point, we've been looking at a fairly high resolution image zoomed in, and you can very clearly see the Tycho crater. But I ask you to think about how big does the moon actually look when you're standing on the ground looking at it from far away. It's a very small object in the sky, if you want to be honest. And something else to note about the Tycho crater is that it has these fairly unique rays emanating away from the center, which actually make it much easier for the eye to see the center of those rays, and we can perceive that the crater is there. So in my example, again, can you see a roughly 2-inch number from 1/10 of a mile away? Perhaps. Or, can you actually see the Tycho crater very well with the naked eye, standing on Earth? Perhaps. Let's think of it another way. If you apply the formula used to determine the proper height of a letter in millimeters used on a vision chart, a 20/20 letter if you will, and apply that calculation to our object a tenth of a mile away, we see that a 20/20 vision acuity letter would have to be 9.215 inches tall in order for somebody with the standard 20/20 vision to be able to read that letter. So maybe a 2-inch tall letter is not big enough to see. But we're not talking about seeing. In this case, we're talking about, can you read the letter? Can you see an object that's smaller than a letter that you can read? Absolutely. What if I put a letter on the Tycho crater? At this zoomed in image, you can fairly clearly see that this is a lowercase letter e. But as I begin to zoom out, the letter gets harder and harder to read, though we can still see it. My point here is, this video does not disprove that the moon is as large as the scientists say it is, or that it is as far away as the scientists say it is. Certainly, they could be lying to us, and the moon could be much smaller and also much closer. But this idea about being able to see the Tycho crater with the naked eye while standing here on the surface of the Earth really doesn't prove anything. Thanks for watching all. Please comment, click, subscribe, join us in the man cave.